Hi everyone, myself Utkarsh from Group A2 from Department of Computer Science and Engineering. In this video, I'll be walking you through the demonstration of image-driven interactive system using vision learning and natural language processing. We have cumulatively implemented this project under esteemed guidance of Dr. B. Srinivas Rao sir, Professor, Department of CSC. My teammates are Bhavan, Laliteshwar, and Vipul. The abstract of our paper is the aim of the project is to create a visual question answering system that utilizes a convolution based natural language processing model within the Transformers library. Visual questioning answer, abbreviated as VQA, is a field of computer systems that deals with the development of models that are capable of answering questions based on visual input. This has gained significant interest with the rise of deep learning and the availability of large datasets. For this project, the modules and libraries that we are using is Streamlit. Streamlit is a framework which empowers us to create interactive web applications. Primarily, it focuses on giving tools to create user interfaces. Second, PIL. PIL stands for Pillow or Python Image Library. It is used for loading and processing images, converting into bytes for optimized search results. Bytes.io. We are using this to load using core optimized bytes and pixels of the uploaded images. We are also using pre-trained data sets from the Hugging Face website. Now let us dive into the demonstration of the image-driven interactive system. As you can see, this application has a very simple and intuitive user interface for users to use it immediately. On the this whole application is divided into two sections, wherein one first section is the image upload section, and the right part of the application is the output section, where users can ask questions and get answers based on their queries. This application supports PNGs, JPEGs, and JPEG image formats. And the maximum limit that the maximum size of the image that the user can input is 200 MB. Let's see with a few examples how this application works. As you can see, as soon as I upload the image, image is loaded, and you see this image in a very beautiful fashion. Now let me ask a question. The users can click this go button or press enter for the model to start querying. Let's say I press enter, and you can see there is a response that the model is working. You see, the question was what is there in the image, and the answer is panda. What is the color of panda? See, the panda is of black and white color. That is what the application gives us. Let's say I ask how many persons are there. Let's see what it gives. As in this image, there is no person or an individual. The output is zero. Now, as soon as I click into this cross button, the application reloads the responses. Let's ask and check if this works in other uh, images also. I upload the image and ask again, let's see how many persons are there. The answer is zero. Let's say how many parrots are there. Now let us see how well the interpretation skills of this application is based on the text input. Let me upload an image and write the question as you can see, I have intentionally made a typo here in spelling of contents. Let's see if it is able to answer the query. The answer is cars. Let's ask how many objects are there in the image. Many. Let's say how many cars are there in the image. As you can see, there are 1, 2, 3, 4, 5, 6, 7, and 8 visible cars. So the answer is 8. This question pattern or this style is not mandatorily. This model is trained multiple times by us so that this language style can be changed to get accurate answers and for it to cater multiple or different individuals. L- Let me ask um, a question which is a bit decision making. What should the drivers do? So there is a traffic jam. So the application tells the drivers must stop at the traffic jam. This is the entry point of our application. In this application, we have divided this complete application into various modules and functions and submodules for easy maintenance. This is the entry point of the application, which is wrapped inside a try catch blocks to avoid any exceptions and avoid crashing of the application. Here, we open the image using the pillow library and convert it into the RGB format, which the model technically expects. Then the processor converts the images and texts into specific formats that it can understand, which are known as tensors. We then pass the processed data into the model that analyzes images or image and questions, generating scores which are logits for each potential answer choice. Then we find the index of the answer with the highest score, which indicates the most likely answer. And then the model configuration helps us map the index back to the model answer text using the id to label dictionary. Now, one of the most important functions of this application is avoiding or reducing the loss while calculating or converting the images to RGB format. For this, we use cross entropy loss. The purpose of this method is to calculate loss for a single label classification problem. It measures how well the predicted probabilities, that is, logits, from the model match the actual class labels in the training data which we have. The input for cross entropy loss is a tensor containing unnormalized logits for each class, typically the output of a classification model. The size of the tensor can be C for unbatched input, mini batch C for a mini batch training, or even higher dimensions. A tensor containing the actual class labels for each sample. This can have class integers indices which are integers between 0 to 1. It also takes a few optional arguments like none, mean, sum, which are basically none stands for no reduction, that is returns a loss for each sample. Mean, it calculates the average loss across the all samples. This is a by default option. And sum, it sums all losses across all the samples which have been generated. The output is usually a scalar value representing the overall loss of the mini batch. So these are various code files which incorporates losses, token classifications, generating logits again and then storing them of the previous batch. Then we have various image processing for different sizes and exception checkings. For conversions, we have also used Coco dataset. Thank you. That's it by Group A2 CSE. Project title Image Driven Interactive System Using Vision Learning and NLP.